Hello, how's everybody doing today? This is actually in your book. This is section 2.7. This is two variable inequalities. And at the end of the day, your I can statements for today are graphing linear inequalities and graphing absolute value inequalities. So since we can already graph linear equations, you guys can all graph a line. And we've been working these last few days on graphing absolute value equalities. This lesson is just a continuation of that. Okay, so it's good practice on those equalities and adding the inequality into the mix. All right, let's go ahead and getting started. It's pretty much what you would expect as far as you are going to, if you have an inequality here, y is greater than 3 over 2x plus 1, what you're going to do is you're going to graph the equality first, right here. So we all know how to graph a line. And I'm actually going to go ahead and make this a dotted line because that's the only adjustment I'm making for this right here. Because just like we used open circles, we use dotted lines, right? So I go up 1 for my y-intercept, plot the point, and then I go, my slope is 3 over 2, so up 3 over 2, plot the point. I'm just going to go up 3 and over 2 again, so I get a nice for this guy, and up 3 over 2, and again I go down 3 and left 2 as well, just to get a nice picture of what it is I'm looking at. Okay, arrows on the end are appropriate here, and arrow going this way, and that's my dotted line right there. Okay, now this is kind of your key. I'm going to shade the truth. Okay, I'm going to shade the truth. So for example, 0, in other words, I'm going to substitute a point into the original equation, and if it makes a true statement, that's shaded. If it's a false statement, well, we shade the opposite side of the line. Okay, you got to be careful. Typically, above, you're thinking we're going to shade above here, but we just need to verify that with a checkpoint. So 0, 0, I'm expecting that to be false. So I'm going to plug in 0 for y, use my parentheses, greater than 3 halves times 0 plus 1. Let's see. Is 0 greater than, let's work this out, 3 halves times 0 is 0, plus 1. Is 0 greater than 1? Well, no, it's not. So false. So this point 0, 0 is false. See that nice big red dot there? Okay. So that means none of those points on that side of the line are true. So I have to go to the opposite side and shade thusly. Because that what that yellow indicates there is that all these points over on this side of the line are in my solution set. So if I picked a random point here, go ahead and in green here, I'm going to pick, I don't know, 0, 5. It should work in my equation. So 5 is 5 greater than 1. Yes, true. So that's an appropriate shading. Okay? All right. Questions or concerns? That's your basic process right there. Okay. All right, let's go ahead and work an example here where the restaurant has 15 eggs to last until the delivery. Okay. So in order, scrambled eggs requires 2 eggs. So I'm going to underline that. Scrambled eggs, 2 eggs. An omelet requires 3 eggs. Write an inequality to model the combinations of orders, okay? So basically, we'll call the scrambled eggs X and the omelet eggs Y, the omelet, if you will. So if I want to make a scrambled egg order or a omelet order, basically I'm going to say 2 times the number of scrambled egg orders plus 3 times the number of omelet orders. I've got 15 eggs, so less than or equal to. I can use all 15, right? I can have the or equal to there, okay? So this is going to be a solid line, All right. And I'm going to go ahead. I know you can use the cover-up method and graph this, but I'm going to go ahead and my preferred method, just to be sure that I'm accurate, is to get it in slope-intercept form. So I'm going to go 3y less than or equal to minus 2x plus 15 divide. Okay. And so now I'm going to make a solid line. Go ahead and let's do that in red. So 5 is my y-intercept. And then down to right 3, negative slope line, what I'm expecting, down to right 3. I'm going to come back this way and go up to left 3 as well, and put my solid line in right there. Okay. Now, in this case, since I have the number of eggs, and eggs can't be less than 0, I'm going to go ahead and just get rid of this part right here. Right? You can't have negative eggs, right? Or negative orders. All right? So basically, that's my solution set right there. And the deal is, if I want to shade this properly, I mean, I know it's got to be less than. I'm going to assume, in the interest of time here, I'm going to try to keep this moving. We're going to go right in here, and all these points are going to make a true statement in my original inequality. So I'm going to go ahead and verify that with the point 1, 1. Okay, and this should make common sense. If I have one order of scrambled eggs and one order of an omelet, well, am I less than or equal to my 15 eggs? Heck yeah, I've got 5 eggs there. 5 is less than or equal to 15. Okay? All right. All right. Let's see here. Just for a quick, this is the pretty picture they used. When the book did this, they went ahead and used the 15 halves because they did the cover-up method to find the intercepts and graphed it that way. Okay? All right. All right. Oops. Okay. Now let's do the same thing with absolute value, okay? So for the absolute value, the first thing we're going to have to do is go ahead and find the vertex, okay? So 2x equals 0, the stuff inside. X equals 0 over 2, which is 0, okay? Y, from our lesson yesterday, we know that we're down 3, right? So the y value is 3, negative 3, excuse me. So again, but you could just substitute that in there if you weren't for sure. Okay? In other words, once you found x was 0, you could plug in and see what y is. So at 0, negative 3, plot the point. Okay? And now, again, we can go one left and one right, and anticipating that that slope's going to be 2. So let's see. So if x is 1, let's just make our t-chart. Real simple, quick and easy. If x is 1, plug in 2 times 1, take the absolute value of that, subtract 3. 2 times 1 is 2, absolute value of 2 is 2, minus 3 is negative 1. Okay, plot the point. So go ahead and look at negative 1. Let's go to the left. And I'm showing these substitutions just to be real clear about what's happening when you substitute in the absolute value. I want to make sure that everybody has that. So order of operations, 2 times negative 1 is negative 2. Absolute value of that is 2. And then 2 minus 3 is negative 1. Okay. All right. So now we get our v there as we anticipated. And I'm just going to go like that. So we got consistency there, and then line going up, solid line here, solid line there. I'm anticipating above to be good because it's a greater than, but let's go ahead and down here at the bottom I'm going to check 0, 0. So I'm going to plug in 0 for y and 0 for x and see if I get a true statement. Is 0 greater than negative 3? Check. All right, so we shade the truth. Use the green this time just for fun. And there you have it. All right. Oops. All right. Hopefully none of you are trying to rush to the guidance office right now. Anyway, and there's the pretty picture of that. So I've got one more example for you. Okay, one more example. Last one. And this is the example kind of going the other direction. Okay, you got the picture. What's the equation? Okay. Uh, so this one, you've got an inequality. This is kind of nice because they gave you, in this case, they gave you, whoa, uh, a nice picture. Okay, I'm looking at example A here. Right, an inequality, the boundary line is given. Okay, so they said, okay, the vertex is right 2, down 1, the slope is 1, and they gave you as a dotted line that guy. Okay, and they shaded above. So I'm going to anticipate um, y is greater than, not greater than or equal to, because it's a dotted line, uh, x minus 2 minus 1. And all I really need to do is run a checkpoint real quick. Let's see. 0, 0 is not shaded. I like 0, 0 because it's easy to use. But let's see here. If x is 2 and y is 0, that should be a true statement. Okay. So if I anticipate right with the greater than. So the y value is 0. We got 2 minus 2, 2 for x, minus 1. Is 0 greater than 2 minus 2 is 0, 0 minus 1 is negative 1. Check. So my anticipation right here was correct that it was going to be greater than. Okay. Last one. Do the same thing with a linear situation, part B here. Okay. All right. So I'm anticipating that this is going to be a less than. And or equal to because it's a solid line. Okay. But to check this, I'm going to plug in 0, 0. Okay, and hopefully it's true because it's already shaded there. So let's see. Is 0, oops, less than or equal to negative 1/2 times 0 plus 3? Is 0 less than or equal to 3? Check. So again, my anticipation was correct. And we've got this done. Okay? That's your lesson for today. That's 2.7, section 2.7. Right now you can write in a linear inequality. You can write an absolute value inequality. You can recognize from the graph what that equation would be. Hope you're having a great day, and we'll talk to you soon.